And so this test is only on the second kind of half of it, which means we're going to be talking about refraction, the way light bends. We're going to be talking about lenses, right? And then ultimately we'll be talking about color. So in terms of our note here, and I'm going to get a different pen to write with because I don't want to write with that one. Get rid of that. And we'll get rid of this. So this is Unit 2, Test 2, Review. All right? And the first thing that we talked about, number 1, was refraction. Right? And refraction is the bending of light when it enters a new transparent substance. I'm not going to write that all in. I think we get the idea. It's got to go into something like glass, or it's got to go into something like plastic, and then the light bends. The first thing we did, and this is a good thing to draw, and if you want, you can use your rulers. That's great, but I'm going to just do it kind of rough here. We are going to draw the ray of light coming in, and we're going to describe what's happening there. All right? So I'm going to put a normal, and again, I'm just kind of doing this by hand. And this isn't a mirror anymore. It's the surface. It's the transparent surface, so the water surface or the plastic surface, et cetera, et cetera. And, oh, I'm going to have to change a setting here on this because it's going to shut itself off every 2 minutes. Okay, so that's the transparent surface. This, do we finally know what that incoming ray is called? Incident, the incident ray. Incident. And you know what? Maybe we'll put a hold on Cade's answers and let other people answer. I don't know whether that was you, Cade, or not, but we'll just put a hold on that. And this thing is called the normal, and Max jumps in without putting up a hand. The normal. All right, the normal, perpendicular to the surface. And we saw a ray that wasn't very bright that did that. What is that ray called? That's a reflected ray. Reflected. Typically that's called partial reflection. It reflects a little bit. And look at, I did a terrible job because that's supposed to be angle I, little I. That's supposed to be angle little r. And we already know the rule of reflection. How should I be compared to r? The same. And mine's terrible. You can see that it's absolutely horrific. Now, what we're interested here is the refracted ray. If this is air and this is water, which is fast and which is slow? Which is fast? Yep. Air is fast. Light goes fast in air because it's so thin. And this is slow. So, fast to slow, how should this bend? I'm going to write those rules down, but I'm wondering if anybody remembers. Fast to slow, this ray is going to bend. It's not going to go straight through. It's going to go one way or the other. How does it bend from fast to slow? Yep. Towards the normal. In this case, towards the normal is down. Towards the normal. Remember, our analogy was like the truck, right, or the vehicle coming along fast and then gets stuck in the mud. Then the one wheel gets slow and the other wheel keeps going fast, and it causes that vehicle to pull into the snowbank, right? This angle in here, and it's very tiny, so I'm going to just write it over here, angle capital R, the angle of refraction. And this ray here is called the refracted ray. All right? Now I'm going to just write down those two rules. All right, and I'll bring it back up here. I'm going to write down the two rules. Rule number 1. From fast to slow bends. We just saw that one. From fast to slow bends towards the normal. Towards the normal. And 2 from slow to fast bends and yeah, away, right? If you know the one, you should be able to have the other one. Away from the normal. Away from normal. Okay? All right, and again, my screen doesn't like to stay on, so this is going to drive me crazy. Okay, good. Going to extend the page a little bit. I just want to make reference a little bit to our experiment that we did. It allowed us to see both of these examples. So we took a rectangular prism and we fired a ray in. That's my normal. Again, it's just a sketch. You can use a ruler, but you don't have to. Just saying. And this was air. This is like glass or something, or plastic. It doesn't matter. So air to plastic, which way is it going to bend? Yep. Towards the normal, which is going to be down. So it's going to kind of cut down there. We drew a second normal, and that's not a good normal. It's not even parallel to the first normal, but it's not bad. From glass back into the air, how should it bend? Away from the normal, all right, because it's going faster. And in actual fact, it bends away the exact same amount as which it bent down, because the ray ends up being going in the same direction. And we called that angle E, the emergent angle, right? And the emergent angle is the same as angle I, because it bends back away the way it came. I told you a silly story about my grandfather shooting the window out when he was trying to get a heron, right? And that's, you know, whether he hit it or not, I don't know, but I always imagine him missing it if it was a really big, thick piece of glass, because he wouldn't be pointing at the right spot, because the ray would have been deviated a little bit. So we called that the emergent ray, and it was the same. We did a little experiment on that. That kind of showed us the refraction. Does that sound familiar to everybody? Okay. And I'm going to get really annoyed with unlocking this thing every time. And I should have used a different app. All right. So the next thing we did, and actually, I might do this differently. I might add another page. How do I add a page, you think? Is there a way to just add a page? What if I click this? Ooh, fun, page 2. All right, so page 2 is going to be number 2. Get out of the way here. 2. Total internal reflection. Remember, total internal reflection was a special situation of where we went from slow to fast, all right? And we use that semicircular prism. But I'm going to just write down an example. So let's say here's our normal, and we shine a ray up here. And how did we know it was total internal reflection? How did we know it was just becoming total internal reflection in that experiment? What did we see? We saw a little rainbow because it was separating, and that's because the light ray traveled right along the surface. And right there we had our special angle. That special angle, angle I, became what we would call angle C. And what was that C standing for? Yep. Critical. The critical angle. This is what we called the critical angle. Oops, And I'm having trouble spelling angle. Critical angle. All right? Now, let's say that we have a critical angle, and I'm going to just pick an example. Let's say the critical angle, angle C, is 35 degrees. Let's say that angle in there right now is 35 degrees. Sound like a good plan? We're just picking one. What if then, example, what if I had, and this is a question that appears on the test all the time, but people mess it up. What if I have an angle, all right, that's down here like this. So let's say this angle I, oops, I want to go back. I want to get rid of that. I didn't want to put a C there. Think my erasure is going to work? Ooh, it did work. Nice. Pen. Can we go back to the pen? So let's say here that this angle I is 20 degrees. So I have an angle that's smaller than the critical angle. What's that light going to do? Yep. No, that's incorrect. I would need a ray that's greater than the critical angle for that to happen. You see what I'm saying? So we're now doing the opposite. This is less than the critical angle. It's a tinier angle. What is this ray going to be able to do? Or where's it going to go? What do you think? Less than the critical angle. The question is it reflected or does it escape from the water? Is it reflected or can it escape from the water? Yep. It escapes. So when we have an angle that's smaller than the critical angle, smaller than than angle C, then it can escape. It still bends away, but it can escape. If it's smaller than angle C, the light escapes. L-I-G-H-T, escapes. All right? If I change the situation, and again, I'm going to draw a little normal, and I have an angle here that is now 40 degrees. Now the angle's bigger than the critical angle. What happens to that light? Logan? It reflects all back in. It's totally reflected. So because the angle is greater than the critical angle, it comes back in. 40. Total internal reflection. TIR happens. All right? So this is if angle I is bigger than angle C. Angle I bigger than angle C. If it's right on 35, where does the ray go? Yep. It's just disappearing, but it's traveling. It's not really called a PA yet. It's just on the surface. This again is the surface. This is the surface. We're not talking about lenses. We're talking about the surface of the water. All right? Look at that. Surface. I always run into trouble when I don't use my PowerPoint because I can't spell. So it runs along the surface. All right. So that is total internal reflection. The next thing we talked about was uses for total internal reflection. And I do have it written down, but I think you guys might be able to remember some of them. So uses of total internal reflection. What did we have? Does anybody remember? What were some of the things that we did that kept the light inside? Yep. Diamonds, right? Diamonds. Different gems would count, but I'm going to write diamonds. D-I-A-M-O-N-D, diamonds. And the light kind of gets stuck in the diamond. So the light comes in and it bounces around and does all kinds of things. And then when it does escape, it tends to be a rainbow because it's just getting out. All right? Diamonds. What else? Anybody remember? We had right angle prisms. right angle prisms. And right angle prisms, I could do it two ways. I could have it like this, where it goes like this and like this. All right? Yep. What's an actual use of that particular orientation? What if I put a second one down here like it? This is a periscope. So here it's an example of a periscope. Periscope. If I put a second one, right, going the other way. And if I turn it this way, so that the right angle's at the back, boom, 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 and I turn it around, what was the example of that one? That was binoculars, where I had the two of them and it snaked around twice. This is binoculars. Binoculars. All right. Fiber optics. Fiber optics. And fiber optic cables are used for all kinds of things. Used for computer data transfer. Used in the endoscopes for like looking inside the body. All kinds of different things. Fiber optics. Okay, let me see if there's anything I missed. I did make a little note of it, so I'm just going to check. Just to make sure. Oh, this one here, we also had bike reflectors, right? Remember? Bike reflectors. So if you had that bike reflector with all of those different pieces on the back, the light would come back on it. All right, excellent. So next, and I might as well get another page because I'm getting good at this. What am I at? 3? Next, we talked about lenses. Lenses. A converging what had to be true about converging lenses? There's an example of one right there. What had to be true in terms of its physical shape? Yep. Fat in the middle, thin on the edges. Fat, middle, thin edges. That's a concave convex, but it doesn't matter. All kinds of different ones, right? That's a double. Sorry, that's a concave convex. That's a double convex. They're both sticking out, but you can see there they're thin on the edges and thick on the ends. When we were drawing them, the easy way to draw them is just to have arrows up and down. So the tip of the arrow is supposed to represent the thin part, and as the arrow goes out, that's supposed to represent the fat part. And then we had a mark over here and a mark over here. And then I'm going to shine some parallel rays of light along here. And now we're going to do some labeling. The main line. What's the main line called? PA. Principal axis. Right here, if this is converging, going to do that. That's how we determine that, right? And what did we call this important spot right there? Yep. Yeah. Principal focus. PF. And on the other side, equal distance. SF. The secondary focus. Okay. I'm going to talk first about some. I'm going to first talk about the diverging lens, and then we will get to our ray diagram rules, which is what you're going to put on this page. So first we'll do the diverging one, and then we will get to that. And again, I'm just taking a look, and I used the wrong program here. Okay, so continuing on, make a little bit of room. B, diverging. An example of diverging like this. Characteristics of the diverging lens. Yep. Got thin in the middle. Thin in the middle. And fat edges. And there's your classic kind of double concave, but that's not the way our glasses look. If we use these types of lenses, it would go, these are tricky because you got to have these lines here. So you got maybe a flat curve on this one and a really thick, big curve on that one. That's kind of an exaggerated view of it, but that gives you the idea. All right. Again, a line. I'm going to put that there. This time the arrows go the other way. I'm going to put my 2 marks there. Again, I'm just estimating. Got to be kind of equal distance. Going to have a PA. I'm going to have some rays of light come in. And what do these rays do? How do they bend? How do they bend? Yeah, no one way up. Up and away, but up and away as if they came from that spot, right? And again, up and away as if they came from that spot. And now on the front side, we have our PF, because that's where it looks like it's coming from. So on the front side, we have our PF, and we have our SF on the other side. Okay, so at this point, I'm going to hand you guys a piece of paper, and this is what you're going to draw the rules for. Okay? And again, this is the type of thing that you're going to get to keep for the test. 1, 2, 3, 4. 5 you guys there. 1, 2. You got a blank piece of paper? Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, right there. Okay. So at this point, I'm going to keep going with my note here, but you're going to want to put this on here, and you can put the title Rules for Ray Diagrams. Rules for Ray Diagrams. All right? And A, converging. And make it nice and big, because your paper, you're only going to have 3 things on it. You're going to have the rules for converging, maybe like the top third, the rules for diverging, the middle third, and then keep the bottom for the color part of it. So somewhere down in the top third, take your ruler, draw yourself a nice principal axis. And as good as you can, make a perpendicular lens. And the smartboard doesn't like it if I put a ruler on it. But with your ruler, you're going to maybe want to put your SF and PF at like 2 centimeters and 2 centimeters from your mirror, or from your lens. So I'm going to use like 10 and 10. So holding it in front, I'll go like there, and then I'll go there to that side on the 20. You guys might want to use 2 and 2. Again, you want to draw this, because this is going to be a sheet that you get to use for the lab or for the test. So you want to draw this now, is what we want to do. I am making a video. All right. So PF, SF, and rule number 1, a ray parallel to PA will go through. A ray parallel to the PA will go through PF. PF. So take your ruler, right? Put it up here somewhere. Draw a ray that's parallel to the PA. And I know I'm not using a ruler, but I can on my smartboard, but you can use a ruler. And again, take that ruler and bend it down so that you've got your pencil on the one spot and have it go through the PF. And I did a not bad job on that, but not great. And you can call that rule number 1. Now I'm going to put the other 2 rules on the same picture. When you draw a ray diagram, you have to actually use the rules. Some people who don't go back and practice the ray diagrams, on all the ray diagrams on the test, all they did was put 3 rules. Not going from where the arrow starts. Make sure you go from where the arrow starts. This is not a ray diagram in itself. This is just the rules we use. Rule number 2. A ray through SF will emerge parallel to the PA. Parallel to the PA. So I'm going to start one here, and I'm going to just start it here. I don't want it to cross with this because I'm just drawing a rule. I'm drawing it something through there like that, and it's going to come out parallel. Rule number 2. These rays, by the way, will come from the top of the arrow, will come from the top of the object arrow. By the way, on the test, keep in mind, and I did this last time, I want you to label the object with an O and label the image with an I, just above it or below it, okay? And I'm giving half marks for that. So some of you in a hurry didn't do that, and you lost a few little marks. If you keep that in mind, you'll get a few more marks. Okay, number 3. A ray through the center goes straight through. Goes straight. And again, I'm going to just try to draw something in here that kind of goes straight on through, like that. I'm just going to put a little 3 over there. However you want to do that, that's up to you. Again, these rays would come from the top of an arrow. If I had an actual ray diagram for you to draw, you'd take them from the top of the arrow and you're going to find where they cross. Again, how many rays do we need in order to find an image? Yeah, you just need 2. You just need to find the intersection point of 2 rays. For the second third, you can put there B, diverging. Diverging. And again, take your ruler, draw principal axis. This time put your arrows heading the other way. Again, measure 2 and 2 likely for you guys, just 2 and 2. And I'm going to take a little look and I'm going to just kind of eye it up at 10 and 20. So you guys would be like 2 and 4. I didn't do a great job on that one, but that's okay. My light is coming from the left again, PF, SF. A ray that comes in parallel to the PA. Sorry? Yeah, looks like it's coming from PF. So it bends up and away as if to come from PF. So your ruler goes on PF, right? It goes on PF and that spot and goes up and away. So I'm going to just draw the dashed lines up like this and then the solid line out like that. A ray parallel to PA will bend away as if to come from PF. Rule number 2, and this is kind of a goofy one, and I'm going to start it from the bottom side this time. A ray that appears to go through SF, so it's kind of heading towards that SF. And this is a tricky one, and I never use this rule, but I am going to write it down. It comes out parallel. And I never use that rule because we don't ever have to use it, but it is a rule. You could use it to find the image, but it's really a pain. It's this forward one that you have to extend in behind, and everyone gets it wrong. Everyone wants to extend that one behind, right? But it's this guy that's coming out that gets extended in behind to find it, and so I never use it. It's confusing. But we'll write it down anyway. We will write it down anyway. A ray that appears to go through SF will emerge parallel to PA. Again, don't like rule number 2, but rule number 3 is awesome. A ray that goes through the center of the lens what's that? Oh, here we got 1. And my mistake is I have the ray going too close to 2. Oh, 3. Thanks. But you're right. Look, I got a problem here with this 2. Should I fix that? Can I erase that without making a big mess? Ooh. I can change the size of the eraser. Look at it, it's huge. I'll make it tiny. Okay, I'm ready to go back to writing though. This one here is number 2. This one here is number 3. A ray that goes through the center of the lens? Yep. Comes out in the same way. Goes straight through. Goes straight. And I shouldn't have stopped writing. See, when I stopped writing, I didn't get a perfect straight through, but it's not bad. I'm going to bring that up. Don't panic. I just wanted to give me some room. A ray that goes through the center goes straight. Goes straight through. Okay. Now, I guess while we're at it, before I proceed, on the bottom of the page, you can write this. So on the bottom of your page, what's that? The light thing. So let's just do that right now so that you're done. If your page is full because you covered it up, you can do it on the back. That's fine. I don't care. I'm allowing you to have these 3 things. So let's just put that on there right now. And then those of you who want me to keep it so you don't lose it, I will collect it from you now. Okay. So what are my primary colors? Red, blue, and green. Secondary. Where? Slow down, slow down. Where am I putting the magenta? Magenta. Yellow. Cyan. All right. Do we need to define what these letters mean? If you feel you need to define what the letters mean, like M, you can write down magenta. All right. I think red, green, and blue we're okay with. Does that make good sense? And C, you could put cyan, which is that blue-green. And we could put here Y just so that yellow doesn't feel bad. Yellow, but I think we probably know that the Y equals yellow. And the W, we're okay with white. Okay with white? If you want to define that, you can define that too. So, yep.
I just start out cursive and then go to French.
My writing is a chaotic mess of jumbled letters, so who knows? There's no rhyme or reason to the way I write. Does anybody want me to take that sheet right now so I don't lose it? Okay, put your name on it and then put it on the desk here. I will hang on to them for you, and I will give that back to you at the beginning of the test. Okay? So don't bump my card if you could, because I've got to keep writing. If we could avoid that. Yep, there is one on Google Classroom. Yep. Okay, uses of the lens. Uses of lenses. What are some uses of lenses? What did we see? Glasses are correct, but we save that kind of for the eye and that type of thing. But we'll put glasses, you bet. Glasses. What else did we use it for? Yep. Telescope. We didn't talk about it, but I'll take it. How do I spell telescope? Just one L? I can't erase that in there. We'll get rid of it like that. Yep. How? They don't have a lens on it. Nope, they don't. When you put if you put the little piece on the end and you get a little shape, that's a diffraction grating. No, lasers don't need lenses. No, lasers don't need lenses. Yep. No, periscopes use prisms, but they don't need lenses. Yep. A projector. We looked at the projector. Projector. Magnifying. Magnifying glass. All right. Magnifying glass. All right. That's good. I'm going to start a new page here. And we're almost done because the last things I got to talk about are the eye and the camera and then a little bit about color theory. But we've already wrote that down. So I'm going to start a new page on this one. So what number am I on? I'm doing it by pages, so number 4. That's nice. So for the eye and the camera. Oops. I don't know why I put that there. Oh, I can erase. Eye and the camera. See notes for diagrams and parts. I'm not going to draw an eye and talk about all those parts and those pieces. You've got to go and look at your notes. Your notes are probably on Google Classroom, right? When we went and we did the eye, most of you opened that document and you wrote on it, right? Remember when we did that? That's where you're going to go to study from. So where it says see notes, right? That's Google Classroom. So you're going to want to look at those different pieces. The cornea, right? The iris, the pupil, the lens, the retina, all right? The ciliary muscles. Those were really all of the labels. For the camera, the lens, the diaphragm was that thing that opened and closed. The aperture was the opening. There was then a mirror and a prism, and then there was the shutter and the film. So again, go look at those and go read over what those parts do. I'm not going to do a great big explanation on how the eye works, but you do need to read through that. But some things that we did look at, I just want to look at accommodation, and I don't know how to spell it. 2 C's. Oh, I have no idea. I just massacred it. Accommodation. Just killed it. It's just terrible. It's terrible. That's okay. So, accommodation. So, if we're looking far, right? Remember, if we're looking at things that are far, the light rays are parallel. Here's going to be my eye like this. See, look at, there's my eye. Nice, easy eye. And when they're far, we just need a thin lens. Thin and weak. The lens is thin and weak. When we look way out there, the lens is thin and it's a weak lens so that the rays end up nicely on the back of our eye. Okay? So when we're looking far away, the lens becomes thin and it is weak. When we look close, the rays are spreading out because the object is close. We need a fat and strong lens. so it can bend them back down into position. So when things are close, we need it to be fat and strong. Okay? I am going to talk a little bit about nearsightedness and farsightedness. And then that's going to be all I'm going to talk about in terms of the eye and the camera. And then the rest you're going to have to go back and read through some of the stuff. So, nearsighted. Can see. If you're nearsighted, you can see near, right? You can see near. So, therefore, can't see far. So it's a problem with the far one. So the far one, they bend nicely, but with someone that is nearsighted, there's my eye, here come the rays, and the problem is they cross too early. All right? They cross too early because they're having trouble with the far light. It means that this lens is too what? Too strong. It's bending it too fast. It's bending it too early. So it's too strong. I need a lens to make that thing weaker. What type of lens will make that combination of eyes lens a weaker combination? Diverging. Because I need to spread the rays out a little bit. Therefore, we need a diverging lens. That spreads it out. In actual fact, I can use some color here. That spreads it out a little bit. And then when they try to bend back in, they make it back onto the there. Now my rays are kind of huge. Like they don't enter the top part of your eyeball where it's white. You know what I mean? But I've made it big to kind of accentuate or explain what's happening. So we need a diverging. Need diverging. Am I starting a fire with this guy's glasses? No. Not starting a fire with this guy's glasses. So when you're stranded on a desert island, you don't want the nearsighted guy. You have no use for the nearsighted guy. So if they end up, gravely ill and you've got to choose which person you're going to eat first. Actually, if you wanted their glasses, you might want to eat the far-sighted guy so you could take their glasses. But anyway, we'll talk about that in a moment. Far-sighted. There's a book that they used to have the grade 10s read. I don't know if you guys would have read it. The book's writer is called William Golding, and it has a character called Piggy in it. What's the book called? Anybody know? Lord of the Flies. Have you read Lord of the Flies? Did you have to read Lord of the Flies? In Lord of the Flies, they end up killing Piggy, I think. Does he end up dead in the end? They want his glasses desperately. Because these kids end up on a desert island and they've got to survive. And why did they want Piggy's glasses? They wanted to start a fire, right? They wanted to start a fire. Ah, you see, if you read the book carefully, when Piggy loses his glasses, he can't see anything. He can't see anything far away. According to the writer, it says he can't see anything far away. That means that Piggy in the book was actually nearsighted because he couldn't see far. But yet the writer says they needed Piggy's glasses in order for them to light a fire. But if he's nearsighted, they wouldn't be able to ever light a fire with those glasses. So Mr. Golding maybe should have did a little bit of research before he wrote the book about Piggy being farsighted. What's that? In the book they do, but when he loses his glasses, he can't see anything far away. All right. So here we go. Let's draw this one up. Here the rays are coming in like this, and they can't bend it fast enough. So the rays come in, but they can't be bent down fast enough. So in other words, this lens is too weak. It can't bend it fast enough. So what kind of lens do I want to put in front of it to help that out? I want to put a converging lens in front. And what's that going to do? It's going to start to bend the light rays in before it even gets to the eye, and then the eye can do the rest of it and can get it onto the back of the retina and you can see clearly. So it helps the eye by bringing the rays in a little bit. And therefore you need converging. And again, if you're on a desert island, you want the far-sighted guy so that you can get a fire started at some point in time. You don't need the guy to be alive in any way. So like I said, if he's injured and you've got to pick someone to eat first, you could choose the far-sighted guy that would need his glasses to be used for starting his fires. All right? So not only do you learn about science in this class, but you learn about survival as well. Okay, last one. What page am I on? 5? Color. All right. Now, I'm only going to write a thing or two about the color here. And all I'm going to write here is additive. Is it additive or additive? Additive? All right. Color theory. And we just had that down. I'm going to draw it one more time. Red, green, blue. Red and green is yellow, and blue and green is cyan, and that's magenta, and that's white. And I know it's really tiny, but we just drew that on the board. All right? Now, I'm going to stop there. We can have questions that involve filters, where we subtract some of the color away, right? Again, I'm not going to write that down. We just did it yesterday. And we can have questions where I'm shining it on a cylinder, which is supposed to be like a can of paint, and we're going to be subtracting some colors away. So you got to think about what's being removed when doing the subtractive color theory. Now, at this point, I'm going to stop the recording and save it.